Okay, this is Mario once again with my microflight, working on projects, non RC aircraft related projects, but this is the stuff that I do often, when I need to repair something and fix equipment, tools, things around my home here. This is the power, I guess they call this an AM board. I'm assuming that's for an amplifier module. And so this is the one that takes the power input, 16 volts, and then distributes through a regulator to the rest of the circuitry here. This is the bottom section of the board. As I was mentioning in my other video or videos, this is these are the solder end connections here to two of the connectors that were rather almost hardwired with these gray cables there. This is the one that distributes power, that makes the switching, the main switch. So there's 3 on one pad, 3 on the other pad, and nothing more than just a contact turns the keyboard on. Distributes 16 volts from the input, which comes in through here, and then distributes it to wherever the switch is tied to, sends it to the rest of the keyboard. But it also distributes to the power to the regulator, which is that little chip that's sitting right there next to the amplifiers. So as you saw in my other video, the unit's working. I got sound. This is the capacitor that I was talking about that I replaced with the 4700 versus the one that was bad, 6800 microfarad. It's reading extremely low. It's not even reading in the thousands of microfarad. It's reading in the hundreds. So that one's bad. I need to get a new one. But in the meantime, I'm going to keep this one here. This is a grounding strap that was hardwired to the another lead on the keyboard. I needed to cut that in order to access this board. And these are I just replaced these type of circuit board connectors, which are a little more narrow in terms of pin to pin than these guys here. I had to kind of squeeze the pins on these to fit them on these boards, but they're a lot better, and they're the same type of connectors that are on the rest of the board. And so those will get the mating plug that I need to connect to the wires that are on the keyboard. That are those gray wires that look like this, that just simply would plug before on these crappy connectors here. And maybe they're not crappy, maybe they do have an application, but in this case, because you need to remove the board, I don't know why they didn't just make connectors like that so that you can remove everything, disconnect everything nice and easy. These you have to pry it a little cap that locks in place, and and they're a lot more troublesome to insert them exactly because they tend to bend a lot easier as you're inserting them. And there's risk of shorting them. In the case of the power, it doesn't matter because you can short any of those leads and it just provides power to the rest of the circuitry. But this one right here distributes which one is it? This one right here. So when I just replace this one, distributes sound to the speakers, and I think it may have some input, a couple input pins there coming into this board, and then sending audio back out to the speakers. So I've already done that, and now I just have to get the mating connectors from my supply here and put them on the cables that are on my keyboard. So I have to go get my keyboard and do that so that I can connect to these a lot easier, to serve this if I need to in the future. I'm hoping that I don't have to do this again for a long time once I replace this capacitor. The board seems to be working just fine, perfect order. I have not tested the microphone, but it's something that I'm going to do. I did test my op amp here, my dual op amp, which does all the processing of the input signals that come into this section right here, the section that's dotted by that white line there. This is my input on the microphone side or instrument side. This switch allows you to select microphone input or instrument input through this phono jack here, and this adjusts the gain of the input signal that goes to the op amps. The op amps are doing nothing more than comparing that signal with a set level that's also connected to the switch here, high and low signal level. That's all that's doing. As I said, that connector is just fine. That connects to the rest of the keyboard, so that op amp is working just fine. And if you just want to see what my op amp tester looks like, it's that unit right there. That is connected to this clip here that allows me to clip into tiny little chips of that nature. Otherwise, you can just connect the chip directly to the socket here. This is just a basic socket for an 8-pin socket, and this is basically my op amp tester here. You can download these circuit diagrams from the internet, or you can make one yourself if you know what to do. But this basically remains on when the circuit's turned on. This needs a 6 to 12 volt input, and when the op amp is working, these LEDs flash. This is not my circuit. I downloaded this from the internet just to speed up things here. I needed a tester, a quick tester, and so I built this because I have all the components. As you can see there, I have pretty much a bunch of components that I can use to make my own circuit boards. I kept all those components as a hobby because I also work on little radio control airplanes, and sometimes I make my own lights, my own circuits. But this is something I downloaded. Just is a quick build, and it works just fine. Just to test that that IC chip. But anyway, so I'm about to put this board back on the keyboard and work on the connectors on the wires that connect here. I need to go in and do that on the keyboard. So that'll be another video, but this is just another video updating on the sequence of steps that I'm taking in order to do this, and what I think should have been done by Yamaha originally from the start. Just if you're going to supply that type of connectors, why not just go all the way and not keep these silly connectors here, that are so difficult to remove when you're servicing this. It's a lot easier just to grab a connector, unplug it, and not keep certain ones directly connected to the board. It's this cable right here that I also had to put a connector there, a bullet connector there, so I can disconnect this from the rest of the board. Actually, this one it's got this cap here because I was doing that just to test the board, but I'm gonna have to solder that wire also to this connector here, so it's more permanent, but can be disconnected in the future as these other ones here. So stay tuned for the last part of this video, hopefully.